Hello everyone, so welcome. In this video series I'm gonna I'm gonna teach integration by partial fraction decomposition. But actually it's a very big topic, okay? So what I'm gonna do is first I'm gonna focus on just partial fraction decomposition, because partial fraction decomposition is a very important topic, not only in integration but it shows up in many areas of mathematics. So let's first try to learn partial fraction decomposition clearly and very well, and then from there we can proceed into integration. Alright, so let me start with fractions, because partial fraction decomposition of course involves fractions. So let me give you a couple of fractions. How about 1/2 and 3/5? How about I ask you to add them? So this is what we do most of the time with fractions, right? We add them, we subtract them, we multiply them, we divide them. So how about if I ask you to add them? Well, how about if I ask you to combine them? So let's use that word, combine. So here the common denominator is going to be, if you look at 2 and 5, it's going to be 10 and it's going to be 11. I hope you know how to add fractions, okay? That's the assumption I have. So I can easily add these fractions. This is what we get. Okay, so given two fractions, I combine them. Alright, so let's try to do the reverse. What do I mean? How about if I give you a single fraction? 3/5. Now I want you to write it as a summation of, let's say, couple of fractions. Write it as a summation of two fractions. Can you think of two fractions? Well, how about 1/5 plus, let's have 5 here. What do you think the numerator here should be? 2, right? So denominator is same, so we can keep 5. 1 plus 2 is 3, so 3/5. So what I did here in this step is a reverse problem of the first problem. In the first problem, two fractions were given, so I combined them to get a one fraction. Now in the second problem, one fraction was given to me. I teared it apart, okay? I broke it down to couple of fractions. So the right name for it is I decompose 3/5 into two fractions, okay? Oh, I can do it in this way also. It does not need to be addition. How about subtraction? 4/5 minus 1/5. Still it would give us 3/5, right? So there are so many ways you can do this. All right, now that is what partial fraction decomposition is. We are given a one fraction and we want to decompose it into several fractions. It could be subtraction, it could be addition of several fractions, it could be combination of both addition and subtraction, okay? All right, so the idea here is that why do we need partial fraction decomposition? So think about a fraction like this: x/3 plus x squared plus 3x plus 2. Now this is a big fraction. Now this is a rational function, meaning a polynomial over a polynomial. Numerator is a polynomial, denominator is a polynomial. This is a complicated big fraction. Let's think it like that. The partial fraction decomposition is you take this complicated big fraction and broke it down or tear it apart or decompose it into several simpler fractions. Now once you do partial fraction decomposition, what you would get here is 2/x plus 1 minus 1/x plus 2. Now compare these three fractions, the fraction here and the fraction that I highlight from green color. Which one are the simpler fractions? Well, the fractions that I circle from green color, they are simpler than what we started with, right? So that's the whole idea of partial fraction decomposition. Rather than dealing with this big complicated fraction, we deal with its new version, where in this new version, okay, this is the new version, we only have simpler fractions. So rather than dealing with a complicated one, we deal with some simpler fractions, but this combination of these simpler fractions still represent that big complicated fraction, okay? All right, so how do you do this? So let me give you the gist of it. Think about a fraction. So let's take 7/10. Now break it down for me to two simpler fractions. Let's say 2. Okay, it does not need to be two fractions, but for this case, let's say 2. Now how do we even start? That's the question. There's so many ways. The way we start here is we look at the denominator. That's the key. We look at the denominator and we look at its factors. So 10 can be divided by 2, can be divided by 5. So 10 is actually 2 times 5, right? So I'm going to pick my denominators to be 2 and 5. What are the numerators going to be? That's what we have to find. Okay, so we choose our denominators of the simpler fractions based on the factors of the denominator of the big fraction. Okay, so I choose factors of my big denominator to be the denominators of simpler fractions. Now the all the steps from here is just to find those numerators. So I will give you numerators. So numerators are 1 and 1. Okay, it works out perfectly and it gives you 7/10. So that's partial fraction decomposition. So here, what do you think is the relationship between x plus 1, x plus 1, x plus 2 and x square plus 3x plus 2? Well, x plus 1 and x plus 2 are factors of x square plus 3x plus 2. Now, here's something you can do. Multiply x plus 1 and x plus 2 and see what you get. Okay, do it as an exercise and see what do you get. So the whole idea of partial fraction decomposition is two things. You're given a big complicated fraction, you're going to break it down into simpler fractions. You're going to rewrite it as a combination of several fractions. Okay, and we construct these simpler fractions using the factors of the denominator of the big fraction. Okay, that's partial fraction decomposition. So I'll teach you properly partial fraction decomposition in the next video, starting from next video. So I'll catch you there. Thank you very much.